rational functions. It's a little bit better. Hopefully it doesn't. Does it kind of fade less with the light off or with the light on? On? Oh, okay. Okay. Now, if you remember exactly what a rational function is basically just a fraction with a polynomial on the numerator and denominator. Numerator and denominator. And let me clean this up a little. Okay, now the general definition is where you have some function of x is equal to, sometimes you'll see p of x over q of x or m of x over n of x. Basically just states we have your lead coefficient and exponent plus your second plus all the way down to your x coefficient and exponent plus your constant coefficient, all divided by another function with a different, possibly different lead coefficient and lead exponent, plus your next coefficient and your next exponent, all the way to your x coefficient and exponent. Uh-oh, forgot to put b of 0. That should be b of m, not a of m. Plus b sub 0. So really m and n could be equal, but it's no guarantee that it's always equal. That's why they're different variables. Same with a and b. They could be equal, but no guarantee they are. All right. Any questions on that so far? All right. Leave that up for a few more seconds. All right. Now we're going to find our intercepts to kind of guide us as to what effect they have on our rational functions. Oh, thank you. Of a rational function. Okay, and these intercepts just describe what they call asymptotic behavior. Asymptotic behavior. Okay, so first we'll start with the old standby, the x and y intercept. Okay, we know to find that, remember you just have to make y equals 0. Or in some cases, f of x equals 0. And your y-intercept you find that by making your x equal 0. Okay, so for example, if we wanted to decide what is the y-intercept for f of x equals, let's say, x minus 3 over x minus 7 all over x minus 8. Let me see if I can clear that up a little more. Okay, so we know that the y-intercept just means you make x equal 0. So we know that f of 0 is equal to 0 minus 3 times 0 minus 7 all over 0 minus 8, which becomes negative 3 times negative 7 all over negative 8, which is negative 21 over 8. But our actual y-intercept point is 0, negative 21 over 8. That's our actual y-intercept. Okay. Same thing with the x-intercept. Okay. So what if we wanted to find the x-intercept? So find the x-intercept for, let's say, f of x is equal to x minus 12 over x minus 4 all over x minus 3, x plus 1, and x plus 2.
What is it in the denominator? X plus 1 and...
X plus 2. Probably can give that a little more room. Say x minus 12, x minus 4, x minus 3, x plus 1, x plus 2. That's a little bit better. Okay. Now remember, with your x-intercept, you just make your f of x equal 0. But before you start, you want to remember that 0 divided by anything is going to give you 0. Except 0 divided by 0, which is an indeterminate form, which is covered later on. Or anything that does not equal 0. Okay. So we know that our x-intercept just means we make our f of x equal 0. Okay. So that means that we have x minus 12 over over x minus 4 over x minus 3 times x plus 1 times x plus 2 equals 0. But 0 divided by anything will give us 0, so really all we need is our numerator to equal 0, and this will be true. Which is x minus 12 times x minus 4 is equal to 0. Which, of course, we know that. All we have to do is make x minus 12 equals 0, or x minus 4 equals 0. Which means that x can equal 12, or x can equal 4. Bless you. So our actual x-intercept is 12, 0, well, x-intercepts, and 4, 0.
So in a situation like that,
Mhm.
on like a test, would we have to do any work for that, or can we just look at the numerator and pick our numbers and go with that?
Well, on the test, they probably won't be that easy, but
Okay.
you'll probably have to factor them first or something. With those, they come pretty much pre-factored for you in this case. All right, leave that up for a few more seconds. All right, so first we're going to look at our vertical asymptote. Okay. That's basically just every x value that x cannot equal. And normally you'll see that with where your denominator is equal to 0. Okay. Okay, so if you remember, any value, of course, that does not equal 0, divided by 0 does not exist. Just a fancy way of saying your denominator can never equal 0. Okay. So that means when you're given I guess you could say a rational expression, you know your denominator can never equal 0, that would be your vertical asymptote for your graph. So your vertical asymptote, it says any value of x that will make your denominator equal 0. Yeah, right down here. Okay, so let's say, for example, well, the vertical asymptotes for say f of x is equal to x squared minus 36 divided by x to the third minus 2x squared minus 24x. Okay, so the first thing you want to do is factor out your numerator and denominator just to see if anything can cancel out first. Okay, so you want to factor your numerator and denominator. Okay. So we know the x squared, I'll just put that over here on the side. X squared minus 36 is the difference of squares. So if you have x squared minus 36, you can actually write that as x squared minus 6 squared. And we know the difference of squares is x plus 6, x minus 6. Bless you. Okay, so we know that our x squared minus 36 over x to the third minus 2x squared minus 24x is going to equal x plus 6 times x minus 6 over, and before we factor this one, we can see we can pull an x out of each term. So we might as well get that greatest common factor out the way. So we can go ahead and pull out an x. That will leave us with x squared minus 2x minus 24. Okay, so now we can go ahead and factor that part. Okay, so we don't have anything in front of the x squared. So we can go ahead and factor, I guess you can call it using the direct method. Minus 2x minus 24. Oh, don't need that parenthesis there. Which means we just have to find two numbers that multiply to equal our c. And those same two numbers add to equal our b. Okay. So we know that 6 and 4 equals 24, and they differ by 2. Oh, that should be negative 24. Sorry about that. Our largest number would have to be negative, so that would mean negative 6. So you have negative 6 times 4 is negative 24, and negative 6 plus 4 is negative 2. So we know that this just factors to x minus 6, x plus 4. Okay, so we know we have our x plus 6 over x minus 6 over x, and our x squared minus 2x minus 24 just becomes x minus 6 over x plus 4. Okay. So now we can go ahead and cancel out the x minus 6. Because anything divided by itself is just 1. Okay, so that leaves us with x plus 6 over x times x plus 4. Okay. So remember, to find your vertical asymptote, your denominator can equal 0. So since your denominator can equal 0, that means that this can equal 0. Okay, so your denominator can equal 0. So x times x plus 4 can equal 0. Okay, so we know that x can equal 0 and x plus 4 can equal 0. Well, that one's already solved, so we don't have to do anything else there. Subtract 4 from both sides. We know that x can equal -4. So 0 and -4 are your two vertical asymptotes. All right, so any questions on that one? All right, I'll leave that up for a few more seconds. Okay, so now we're going to look at our horizontal asymptotes. And that's literally just either how, like a kind of a bound as to how high or how low your graph can go. Okay. So what if we let our f of x equals, remember we have our lead coefficient and our lead exponent, plus our next coefficient and our next exponent, and it goes all the way down to our x coefficient, and then our constant coefficient, all over our denominator. Instead of m, we'll make that b sub m, since we don't really know if they'll match or not. And it goes down 1. Look, b sub 0. Okay, so we have all of our coefficients, we have all of our exponents and everything else. The only thing with a horizontal asymptote is that you kind of ignore everything except your lead coefficient. Those are the only ones you'll worry about. You're going to worry about the exponent for those. That's pretty much it. So focus on lead exponents. To find horizontal asymptotes. Okay, so you have 3 different scenarios. What if your numerator exponent, lead exponent, is bigger than your denominator lead exponent? I mean, less than, rather. So let's say if n is less than m. So your numerator, your exponent here is bigger or is less than your numerator, your exponent down here. If that's the case, then the x-axis is your horizontal asymptote. That just means your graph will not cross the x-axis. That's all it means. Okay. Now your second possibility is that those two exponents are equal. Okay. So let's say that n is equal to m. Okay. Now if that's the case, you're just going to get those two coefficients, and y equals those two coefficients will be your horizontal asymptote. So it's just going to be a horizontal line. Oh, that should be then. There we go. Oop. M is your horizontal asymptote. And I'll give you an example of each one so you see how it looks. Uh-oh. Okay. Now, if you have your numerator exponent is bigger than your denominator exponent, then there is no horizontal asymptote at all. That means it can go up forever or it can go down forever. Excuse me. It's going to show up in a minute.